In one game, a code made using different colors is created by one player, the code maker, and the other player, the code breaker, tries to guess the code. The code maker gives hints about whether the colors are correct and in the right position. All right? The possible colors are blue. Let me underline these in the actual colors. Blue, yellow, white, red, orange, and green. Green's already written in green, but I'll underline it in green again. And green. How many four-color codes can be made if the colors cannot be repeated? To some degree, this whole paragraph in the beginning doesn't even matter. If we're just choosing from, let's see, we're choosing from how many colors are there? There's 1, 2, 3, 4, 5, 6 colors. And we're going to pick 4 of them. How many four-color codes can be made if the colors cannot be repeated? And since these are codes, we're going to assume that blue, red, yellow, and green, that is different than green, red, yellow, and blue. We're going to assume that these are not the same code. Even though we've picked the same 4 colors, we're going to assume that these are 2 different codes. And that makes sense because we're dealing with codes. So these are different codes. So this would count as 2 different codes right here, even though we've picked the same actual colors, the same 4 colors. We picked them in different orders. Now, with that out of the way, let's think about how many different ways we can pick 4 colors. So let's say we have 4 slots here. We have 4 slots. 1 slot, 2 slot, 3 slot, and 4 slots. And at first, we care only about how many ways can we pick a color for that slot right there, that first slot. We haven't picked any colors yet. Well, we have 6 possible colors. 1, 2, 3, 4, 5, 6. So there's going to be 6 different possibilities for this slot right there. So let's put a 6 right there. Now, they told us that the colors cannot be repeated. So whatever color is in this slot, we're going to take it out of the possible colors. So now that we've taken that color out, how many possibilities are when we go to this slot, when we go to the next slot? How many possibilities when we go to the next slot right here? Well, we took one of the 6 out for the first slot, so there's only 5 possibilities here. And by the same logic, when we go to the third slot, we've used up 2 of the colors already. So there'll only be 4 possible colors left. And then for the last slot, we would have used up 3 of the colors. So there's only 3 possibilities left. So if we think about all of the possibilities, all of the permutations, and permutations are when you think about all of the possibilities, and you do care about order, where you say that this is different than this. This is a different permutation than this. So all of the different permutations here, when you pick 4 colors out of a possible of 6 colors, it's going to be 6 possibilities for the first one, times 5 for the second bucket, times 4 for the third third bucket of the third position, times 3. So 6 times 5 is 30, times 4 is times 3. So 30 times 12. So this is 30 times 12, which is equal to there are 360 possible 4-color codes.